Professor Mohamed Hamdy. He's my colleague. He's a member of the Faculty of Innovation Committee. He's a strategic leader of the Green 2050 Center, and he belongs to the Building Technology Research Group. Mohamed is an expert in computational modeling, simulation for optimizing the design, operation of the buildings in terms of energy use, energy flexibility, indoor environmental quality, global cost, and other issues. We know because students which we have together are very welcoming Mohamed every time. Today, he will present market simulation towards smart buildings and neutral climate cities idea. And Mohamed, the floor is yours.
Perfect. Okay, so welcome everyone again. So our innovation talk today is about market simulation, and here we are talking about how simulation can be used to support new innovations. So we are not going to talk about one specific innovation, but we're going to talk about how we can support our innovations towards intelligent buildings for neutral climate cities. So as we know, this innovation talk is meant to talk about the technology and also about how we can go from this technology to the market and how to be implemented. So, and just before I start, I would like to give quick background about what we are doing. Actually, EU put a goal to have neutral climate by 2050, to have a neutral climate economy. And for within this goal, we have EU Green Deal, which make strategies to or package of policy initiatives in order to achieve this goal. With the Green Deal, we have EU missions, and this mission actually to bring concrete solutions facing big challenges. And as determined that we have, or EU have 5 missions for now. One of them is to have 100 climate neutral and smart cities by 2030. And this is one of missions which is really representing very big challenge, and that's what we're going to talk about today. In order to achieve climate neutral smart cities, our buildings not need to be only energy efficient, but need to be climate resilient, to be flexible, to be cognitive, and also to be circular. So there is many things are needed, and to be healthy. So many things are needed from the building and to interact on city level. To do that, there is a lot of innovation and technologies have been already developed, and the market now, global energy efficiency market is about $310 billion, as mentioned by IEA, International Energy Agency. So all these solutions, not all of them are easy to be penetrate and to be have a good market share. So here there are many barriers. Many of these barriers related to the technology itself, how to be demonstrated, how to be tested, how to be developed further, and also there is barriers related to the marketing. And before we go to how to market these innovative solutions, actually we have to know how they perform and to demonstrate it and test them under different conditions to be fit on large scale of the market. This is like normal cycle when we want to achieve something and we come with ideas, and then we have to make a prototype, we have to test, and these take like many cycles until it's mature enough, until it go to the implementation phase. To do that, we have different tools to test new technologies in building technologies. I mean here specifically. So we have climate chamber, we have test cell, we have living labs where people can interact, and also we have simulation tools. What about climate chambers? It's like chamber like this one, where the new technology can be tested under different environment, which we created in the lab. So inside this chamber, it can be like a new insulation material, or it can be a new device, can be tested. And usually for devices, it can be with large scale climate chamber like this. But what is the problem with these? Of course, the test conditions are limited, and also it's not possible to interact with people. And of course, we have to buy the climate chamber, which is fit for our test. So it's quite expensive. And if you have room like this, you have to, and you are technology provider, you have to test it and you have to book it and pay money to do that. One of other tools is what we call it full scale climate chamber, where we have like a room inside a building, and we have like usually two similar rooms to test the product under two different conditions. And still, this is expensive. This is how it looks. Some people sitting here, you can provide the environment which you want inside this room. Then we have living lab, where we have living lab, we have interaction with our potential customer, or to test this acceptability of this technology with people. And at NTNU, for example, we have this Z living lab, and even it can be given for people to live inside for, let's say, months, 2 months, or whatever period of time, in order to test how they behave inside this building as integrated design or with innovations. Then we have simulation. We can put everything. We can represent all the physical phenomena related to building physics and also about the environment. All this can be well simulated, including also conductivity, and with the grid and with the cloud, we can test different technologies and smart technologies. So we have this tool, but here, this tool can allow us to test our innovative solution under so many conditions as we wish. Of course, it's cheaper, but it doesn't connect directly with the end user. So there is, and people who go to climate chamber or living lab or test cell, also you have to pay. It's quite expensive, and also it's not fit to be used for marketing, to talk to people who, as decision makers, which you want to show them the potential of your technology. So that's why we want to say technology testing and demonstration is very connected also with the marketing. So when we have usually a case, we want to, let's say, monitor the behavior, and then we have here our technology and the market solutions. And when we add it to the case, the decision maker can start to see what is the impact of this technology and make like recommendation for the decision maker. So here we can talk with the decision maker and make also good marketing. So now we talk about the term which we started with, market simulation, and market simulation allow you to target your market efficiently, and also in strategies or innovation technology can be tried, tested visually, and saving a lot of expenses, and also providing free, risk-free environment of experiment. So here we start to talk about some examples of some technologies or some innovations which has been tested by our tools. So the first technology, we talk about Argel solar wall, and you can see on the top here is the real photos of the case study. On the bottom here, you can see simulation, where we can talk with the decision maker. On left-hand side, we can see traditional windows, how the daylight will be in this room. It was a sport facility, and how it looks. So here you can see the light is not well distributed, and here it can be simulated, and you can see the power of simulation. It can simulate exactly what you can find in reality. So this is like validation of the power of simulation. Here we simulate the new technology, which is Argel solar wall. And here you can see how the light is very well distributed. And by having this visual environment to represent the advantage and also what you can get from innovation, and talk at the same time with the decision maker, it can help a lot of technologies related to building to penetrate the market easily. And that's what we meant by market simulation. And it's not only to visualize, but also we can assess the environmental impact. And by assessing the environmental impact, it's very required because new regulation now, there will be a new tax event for CO2, additional tax for all environmental impact come from creating new technology. So this can be also assessed and provided in with this tool. Another technology number 2 here, it was about a new type of windows. It's not very new now, but I mean like relatively new compared to what we have usually in the market or typical. So thermochromic windows, photochromic windows, and electrochromic windows. And also by using simulation, we can model all the physics, and we simulate it under test conditions, which we wish. And this is just a result of the 3 technologies. And this is a last technology, it's electrochromic. We can see when we have high like daylight, how the building change, the windows change the properties. So we give like electronic signal for the window itself to change its property, like solar heat gain or transmittance coefficient. And here you can see the potential of how much energy can be saved, heating energy, cooling energy, and also the lighting as well. So here we can see the saving. Maybe one lighting can be increased a bit, but the heating and cooling, and especially cooling, will reduce significantly. This one of other technologies also tested by simulation to provide, and this one which I like to talk about it because it's one of the most recent cases we had here, is with a new generation of heaters, where this heater has a mobile application. You can schedule if you are outside the home, you can set the temperature to be lower in order to save energy, and before you come, heater can automatically reheat to the set point, desired set point, heating set point. And this kind of heater has like mobile application, it's connected to the Wi-Fi, but in order to make scheduling, instead of to keep the temperature fixed all the time, this is a challenge, because if the capacity of the heater is not large enough, what will be the problem? You will put the set point to be low, and before you come back to the home, you expect the heater will be able to return temperature to the set point, desired set point. This is not usually the case. If the heater is smaller than needed, because it should be bigger than usual in this case, or if the weather is okay, it's okay to work normally with the same size. So it depends on the weather. It depends on the room where this heater is added, then it will work efficiently or not. So such kind of technology, if you designed and you provide it to the market and people realized it doesn't work as they expected, they will start to hate it and they will not accept this technology, even it's a very good. But by having simulation, we can test it under different environments to fix what size fit for which case, and also how fast the heating should be done. So it's a lot of things related to the program of the programming of this heater need to be considered. It can be considered in simulation environment, some kind of digital twin, to improve the performance of this technology, and this help this technology to be accepted in the market. Actually, this one, it was like a case study with a Norwegian company, Milheat. Maybe many of us know this product or even have it at home. And we, when they came to NTNU first, the idea, it was like they want to test this in our living lab. But even the test condition and to design the experiment, it was not clear. So, and it takes long time, and it will spend so much money need to be for renting these facilities for testing for a long time. What we suggested here, we suggest to use simulation in the beginning in order to make the test, to design the test. And even we get preliminary results from this test to improve the controller, all this with cheap solution because it's based on simulation. And after we sure about what we want to test, what we want to improve in the algorithm, and with this improvement, then we can go to living lab and test it in real condition and also with interaction with people. So this case is recently also published in one of our conference paper, where we test this heater under different conditions and under different also condition of building envelope and weather condition. So a lot of tests have been done. It helped this technology to be developed and the algorithm to consider many points which was not in the beginning like considered. And I mentioned this make the technology work better to be acceptable by people and to avoid any unexpected problems. Here also we show it what is the potential if we go from different size of heaters and how each one can provide good comfort, and as well also how much energy will be saved, because here we also help or test the algorithm developed by the company in order for PIT control to avoid overshooting and some technical problems could happen if not tested or if not designed as should be. And this actually technology is very important because in new, also like new standard ISO 52120, it talk about automation of heating and cooling, not only for residential, for commercial buildings, but also for residential building, where there is no facility managers in residential buildings usually, but then the technology should be we need automation in residential, but it should be very well designed and to be self-tuned, because no people will be responsible or technical people will be responsible on this technology inside residential buildings. And this automation and the new technologies, smart technologies need to be implemented even in residential building in order to help Europe to achieve this goal of 100 neutral climate cities. One technology number 4, which is also we have a joint PhD with the Denson University in Germany, and in this we try to even have like a brain computer interaction for smart building control. So this technology, you can read the signal and make orders from the signal coming from the mind, and it can be given to make some actions to change set point or to change shading or to control different devices. This technology, first, it can be very fit for handicap and people with some problems. If they cannot talk or they cannot take action, then it can be very useful for them. And also we found it can be useful for the decision maker if we track the signal from seeing the technology, what is he is happy toward what and what is not happy with, then this technology also help with simulation marketing. So in the end, this is my last slide, like market simulation allow you to target your market efficiently and test your technology visually with and save expenses and providing risk-free environment for experiment. That's all from my side today. So I hope it make it clear, and we have 10 minutes for maybe discussion, research, and questions. I will be so happy with it.
Thank you, Mohamed, for a very interesting presentation. I'm sure that there are going to be many questions or comments on that.